Hi everyone. I am going to discuss percentiles for ungrouped data. So the values percentiles are the values which divides an array or data into 100 equal parts. Okay? Now, the first, second, up to 99th percentile are denoted by P sub 1, P sub 2, up to P sub 99. Take note, class, that the 50th percentile corresponds to the median, while the 25th percentile corresponds to the first quartile, and the 75th percentile corresponds to the third quartile. So basically, in solving for the percentiles involving ungrouped data, we need to locate the position of each percentile. And then after finding out the position or the order of that percentile, so by inspection, or by doing some calculations, if the position is not a whole number, then we will come up with the percentile value. So we need to work on the percentile position first. So for P sub 1, this is equal to n plus 1 all over 100. So meaning there is a one factor here on the numerator, and whatever the value, it's the nth item or the nth value. And then by inspection, if that corresponds to whole number, we will just locate that on the ordered array of data. And here take note is the total observations. Now for P sub 2, there is a factor 2 here on the numerator, quantity n plus 1 all over 100, up to P sub 99. So there is a factor, constant factor 99 here times quantity n plus 1 all over 100. So let's try to work on each example here. So let us calculate the 13th, 37th, and 64th percentile from the following array. So n here is equal to 20, a total of 20 observations. Now we need to work on the position first. So let's work with P sub 13, and this is equal to 13. Quantity n is 20 plus 1 all over 100. So this is 13 times 21 divided by 100. So we have 2.73 value. Now, since there involves a decimal value, what we're going to do, since 2.73 is within the second and the third value, which are 28 and 29 respectively. So the second value is 28, while the third value is 29. So the difference between the two is 1. And that difference has to be multiplied with the decimal portion of the ordered value for P sub 13 and add the result to the lower boundary, which is 28. So P sub 13 is equal to 28 plus the product of 1 and 0.73. So meaning P sub 13 is equal to 28.73. Okay? So how about P sub 37? So the position is equal to 37 times 20 plus 1 all over 100. So P sub 37 is 37 times 21 divided by 100. So this is 7.77 value. So same with what we did in P sub 13. 7.77 is within the seventh and the eighth value. And the seventh and the eighth value is 1, 2, 3, 4, 5, 6, 39, and 42 respectively. So this is the seventh value, while this is the eighth value. We'll get the difference, and we will multiply the difference by the decimal portion and add that with the lower boundary. So we have P sub 37 equal to 39 plus the product of 3 and 0.77. So P sub 37 class is equal to 90.09. Rather, the value is 41.31. So how about P of P sub 64 or the 64th percentile? So this is 64, quantity 20 plus 1 all over 100. So we have P sub 64 is equal to 64 times 21. Then we divided by 100. So we got 13.44. So this is the 13.44 value. So 13.44 is within the 13th value and the 14th value. So the 13th value here is 61, while the 14th is 67. And we will less 67 by 61. So the result is 6. And we will multiply this by the decimal portion of the position and add the result by the lower boundary. So P sub 64 or the 64th percentile is equal to 61 plus the product of 6 and 0.44. So P sub 64 is equal to 63.64. There. So in this example, take note that the order is not whole number, or the position of each percentile here is not whole number. So we need to do the necessary computation to come up with the percentile value. In the second example, we'll come up with exact value of the position, and what we will just do is by inspection, locate the end value as the percentile value. So let us calculate the 25th, 50th, and 75th percentile from the following array. So we have a total of 19 observations here. So n equals 19. And we are asked to solve for the 25th, 50th, and 75th percentile. Now, 25th percentile class is the same with the second quartile value, rather first quartile value, while this is equal to the second quartile value or the median also. And the 75th percentile is equal to the third quartile. We will see if they have the same or equivalent value. So working on this requires us to locate the position, like P sub 25 is equal to 25 quantity 19 plus 1 all over 100. So this is 25 times 20 divided by 100. So this gives us 5. Okay? 25 times 20 divided by 100. So the fifth value. Now, since the value of the position is whole number 5, so by inspection, we will just count 5. from the ordered array here, 1, 2, 3, 4, 5. So this is now the 25th percentile. So P sub 25 is equal to 360. Now, if you remember, Q1 is, position of Q1 is N1, N plus 1 all over 4. So this is 20 over 4, which is actually the fifth value. So really, Q sub 1 equals P sub 25, which is 360. So how about P sub 50 or the 50th percentile? So this is 50, quantity 19 plus 1 all over 100. So that's 50 times 20 divided by 100. And we come up with the 10th value. So the position is whole number. So by inspection, we will count 1 to 10, or the 10th value, which is 540, is the 50th percentile. So P sub 50 is 540. And this must be equal to the second quartile. So the position for the second quartile is defined by n plus 1 all over 2. So this is 19 plus 1 divided by 2. So this is the 10th value. So really, the second quartile equals the 50th percentile. For P sub 75, so this is 75, quantity 19 plus 1 all over 100. So this is 75 times 20 divided by 100. So this gives us 15th. So this is the 15th value or 15th item. So P sub 75 is 1, 2, 3, 4, 5. So this is P sub 75. And third quartile is equal to the 75th percentile. So the position for the third quartile is 3 quantity 19 plus 1 all over 4. So this is 3 times 20 divided by 4. And this gives us the same ordinal value, 15th value. Therefore, third quartile is equal to the 75th percentile, which is equal to 680. So next example. So let us calculate the 16th, 57th, and 94th percentile from the following array. So here, n is 24. So there are 24 observations. So let's work on the 16th percentile. So let's consider the position. So this is 16 times 24 plus 1 all over 100. So this is 16 times 25 divided by 100. So we come up with an exact value, fourth value. So by inspection, 1, 2, 3, 4. So this is the 16th percentile. So P sub 16 equals 20. Now with P sub 57 or the 57th percentile, so this is 57 times 25 all over 100. So we have 14.25. So again, we're going to consider the 14th value and the 15th value. So this is 12, 13, 14th, and 15th here. So this is 58, 61. We will get the difference between 61 and 58. And this is 3. And this 3 will be multiplied to the decimal part. And the result will be added to the lower boundary. So P sub 57 is equal to 58 plus the product of 3 and 0.25. So P sub 57 is equal to 58.75. So how about um P sub 94? So this is equal to 94 quantity 24 plus 1 all over 100. So we are working on the position first. So this is 94 times 25 divided by 100. So this gives us 23.5. So the 23.5 value. So we have to consider the 23rd value and the 24th value. So which is 94 and 95. So working on the difference between the two, this gives us 1 and we will multiply this one with the decimal portion of the order or position of P94 and we will add that with the lower boundary. So P sub 94 equals 94 plus the product of 1 and zero point 0.5. So P sub 94 is equal to 94.5. So in solving for the percentile, we have to consider the position first. If we come up with an exact value, meaning whole number for the position, so we will be able to locate or identify the percentile value by inspection going through the ordered array. If it's not a whole number, then we have to do some computations like what I have shown to you. So that's it for now.